Welcome to another lesson in which we are going to learn about balancing chemical equations. Now, in this current lesson, the best way to go about this is straight with practical problems to help us understand what we are going to be dealing with. So the first example that we have in this current case, we have N2, which is nitrogen, plus hydrogen, which is H2, is going to give me NH3. Now, the whole point that we're trying to achieve is to balance the reactant side with the product side. Now, anything behind the arrow is considered to be a reactant. Anything after the arrow is going to be considered our product. The whole point is we need to make sure that the atoms before the reaction and the reactant side, they are equal in number to the total number of atoms on the product side. So if I have, for example here, 2 atoms of nitrogen, I should have 2 atoms of nitrogen as well on the product side. However, you do notice that there's something wrong. The numbers are not balanced. This is the whole point that we're trying to achieve. We're going to balance our reactants with our products. And in order to do so, the only thing that we are allowed to do is place coefficients, which are numbers, in these following locations. This is the only thing that we're able to do. We can put a number here, put a number here, put a number here, which is going to multiply anything to the right of it, to help us balance our reactants and products. So let's go about this problem and see how it works. Now, the first thing that you need to do, always write down the reactant side by itself. We have reactants and we got products. Then list down your reactants. We have nitrogen, we have a total of 2 atoms. Hydrogen, we have a total of 2 atoms as well. Now go to the product side. You got nitrogen, we have 1 atom, and the hydrogen, we have 3 atoms. Now at this current stage, you need to compare where is the problem. Now take a look at the nitrogen. We got 2 atoms in the reactants and we got 1 atom in the product, which is not correct. They should be equal. Similarly, for the hydrogen, we have 2 over here and we got 3 over here. So in order for us to fix this problem, we should try to place a coefficient somewhere over here to make things better and try to resolve the problem. So in this current case, we are going to experiment and see what we can do. Now I'm going to pick the nitrogen atoms as my starting point because they seem quite simpler, and I'm going to try to balance them. We have 2 on the reactant side, so I have to make this number to be 2 as well. So in order to do so, I'm going to place the coefficient 2 over here, and this will change the nitrogen count to 2. At the same time, you have to be careful because this coefficient means we get 2 molecules of NH3. So this entire thing is doubled, which means the hydrogen will become 6. 2 times 1 is 1, and 2 times 3 is 6. 2 times 1 is 2, and 2 times 3 is 6. So that's why we have placed 2 over here, and that's why we have placed 6 over here, because 2 times 1 is 2 and 2 times 3 is 6. So that way we have placed a coefficient trying to change the total number of atoms in order to match it with the reactant side. So for the case of the nitrogen, this worked. We have nitrogen, 2 atoms on the reactant side, and we got 2 atoms on the product side. However, there's a problem with the hydrogen. We got 2 atoms on the reactant side, however, we have 6 atoms on the product side. So how can we balance this? How can we balance 2 and 6? What we're going to try to do is we are going to put the number 3 over here and see if this works. 3 multiplied by 2, because we are doing what we're doing in this case, we are saying we have 3 hydrogen molecules repeated over and over again. So H2 plus H2 plus H2, we got 6 in total. So this will mean we have 6 hydrogen atoms. Now let's cross-check. The nitrogen count on the reactant side is 2. On the product side is 2 as well. Excellent. This is balanced. Now go to the hydrogen as well. Hydrogen is 6 on the reactant side, and for the product side is 6 as well. Excellent. Both of them are balanced. So this is the main goal that we're trying to achieve. We are trying to balance our reactants and our products, and we have achieved this by placing the coefficient 3 over here and the coefficient 2 over here, such that our balanced equation would be, we got N2 plus 3H2 gives us 2NH3. This means the reactants, the total number of atoms in the reactant side, is equal to the total number of atoms on the product side. Let's have another example. In front of us, we got P, which is phosphorus, plus oxygen, gives us P2O5. Now, the whole purpose is we need to balance the reactants with the products. Again, follow step number 1. You are going to separate the reactants from the products and count. Now for the phosphorus, we got 1 atom. For the oxygen, we got 2 atoms. That's on the reactant side. Now shift to the product side. On the product side, phosphorus P has 2 atoms, and for the oxygen, we got 5 atoms. Again, if you compare both of them, the reactant side and the product side, they are not balanced. And based on the law of conservation of matter, we are simply rearranging the atoms. We're not creating or destroying them. So it means the reactants should equal to the products in terms of the number of atoms. Now let's try an experiment with this. So the first thing that we can try to do or try to achieve, what if we experiment with the oxygen, let's say. Now the whole point is for you to try and experiment balancing them with the hopes that you get the correct answer. So let's try to do this. We got 2 on the reactant side and we got 5 on the product side. Always try to compare this to the multiplication table. What is in common between 2 and 5? 5 times 2, 2 times 5, we got 10. So what if I go ahead and place the number 2 here? This will change my count to 4 for the phosphorus and 10 for the oxygen. Why? We got 2 times 2 is 4 and 2 times 5 is 10. Now, how can we balance this on the product side? How about if we put 5 over here? 5 times 2 is 10. So this will change my oxygen. And we put 4 over here. And this will change my phosphorus to 4. Now, if you compare both sides, we got phosphorus to be 4 on the reactant side. We got phosphorus to be 4 on the product side. Oxygen, we got 10 atoms on the reactant side. Now we got 10 atoms on the product side. So in this case, my reaction is balanced. We need 4 atoms of phosphorus plus 10 atoms of oxygen in order to give us 2 molecules of P2O5. So you get the picture over here. You start by counting the total number of atoms on the reactant side, then you go to the total number of atoms on the product side and try to match both of them by adding coefficients at these following locations. Now let's try and solve another example before you try to attempt a problem by yourself. Now this is example number 3. We got sodium chloride, NaCl, plus fluorine gives us sodium fluoride plus chlorine gas. Again, follow the exact same steps. Step number 1, the reactants side. Step number 2, we got the product side. Now let's write down the atoms that we have and their count. We have Na, we got 1 atom. Cl, we got 1 atom as well. Fluorine, we got 2 atoms. Now go to the product side. Na, we got 1 atom. Cl, we got 2 atoms. And fluorine, we got a single atom as well. Now, if you compare both sides, sodium on both ends, or Na, is balanced. However, we got a problem with chlorine and fluorine. Now, what is in common between 1 and 2? The actual number 2. So let's try and toy with this and see if we are able to balance it somehow. What if we try to balance the chlorine in this case? Cl, we got Cl1, one atom, and 2 in this case. So let's try to add the number 2 over here. Trying to balance the chlorine. The chlorine will become 2 in numbers. However, the sodium will become 2 in numbers as well. Now we've got to try to fix this problem. We balanced the chlorine, but we messed up with the sodium. So let's try to fix this problem by adding 2 over here. So by adding 2 on this side, sodium became 2, and you have to be careful, fluorine became 2 as well. So by doing this step, we were able to balance the fluorine as well. So you notice, sometimes when you are attempting to balance a specific chemical equation or chemical reaction, it could resolve itself by itself as you place the right coefficients. Now let's compare. The number of atoms for sodium, Na, is 2 on the reactant side, which equals to 2 on the product side. Excellent. Chlorine, we got 2 on the reactant side, which equals to 2 on the product side. Now for fluorine, we have 2 on the reactant side, which equals to 2 on the product side. Simply we're able to do this by adding the following coefficient, 2 over here and 2 over here, and our chemical equation is balanced. Now it's your turn to apply the concepts and try to balance this following problem, where we have potassium hydroxide plus phosphoric acid gives me potassium phosphate plus H2O. Now without getting caught up with the naming, we got potassium, which is K, oxygen, which is O, hydrogen, which is H, again hydrogen, P is for phosphorus, O for oxygen, K for potassium, P for phosphorus, O for oxygen, H for hydrogen, and O for oxygen, in case you're not very comfortable with using the periodic table yet. Now the whole purpose is, or the whole point is, you are going to try to attempt to balance the reactant side with the product side. Now once you are done attempting to solve the problems, make sure that you write down your answers in the comment section to cross-check for the correct answer with the other members of the community.